Hello everyone, I'm Allan Carson and welcome to the latest installment of the World Nuclear Association video series on innovation. In this series, we will be asking leading industry figures about what is needed to facilitate nuclear innovation and bring new technologies to market quicker. The demonstration of advanced and small modular reactors over the next few years will mark the beginning of a profound change in the nuclear technology landscape. However, innovation is not only about technology, but also encompasses areas such as regulation, financing, and communication, all areas that are currently preventing nuclear energy from reaching its full potential. With that, I am pleased and excited to be joined today by Gilles Rodriguez, Technical Director of the Generation 4 International Forum. Gilles, I would like to start by asking you about your role as Technical Director at GIF. You're very much at the forefront of supporting the development of the technology that will support the next generation of nuclear reactors. And I was wondering if you could elaborate further on some of the areas of innovation that are being researched and what benefits they may bring.
So, in fact, on Gen 4 International Forum, we are working in parallel to six innovative systems that we believe to be important or interesting for the fourth generation of reactors. So today, PWR, pressurized water reactors, are considered as Gen 3 reactors, and Gen 4 are advanced reactor. We call them also like sodium fast reactor, lead molten salt reactor, gas fast reactor, supercritical water reactor, and I'm always forgetting one, but very high temperature reactors. So we are working in parallel with these six systems. And so we are making innovation. Some of these systems are quite mature because they already have some operating systems. Sodium fast reactor, for instance, or high temperature reactors. Some others are challenging, and so there are some innovative systems by themselves. Molten salt reactor was studied in the 50s at small scale, but we want to raise them at higher scales, and so it's quite a challenge. So some of these systems are already innovative by their concept. Even for the mature systems, of course, we are making to improve them, so to make some innovation to improve in the way of having a higher safety, higher efficiency, or sometimes cost reduction, so higher benefits also. And so we are going and making some R&D roadmap, considering the technical readiness level of every systems, and also to see the target we want to have to every systems. But this is not the case, because this is not only the fact, because in that case, we'll say that we have only six systems working in parallel with no interconnection between them. And so we have made also some cross-cutting working groups or task force where there was some common shared challenges on reactor safety, on economics, on safety design criteria, safety design standards, proliferation resistance, and physical protections. So we have some kind of cross-cutting systems where we can share the knowledge, and when we can see beyond some innovative system that could gain to all the six systems. And two specific task force are completely devoted to innovation. One is called Advanced Manufacturing and Material Engineering Task Force. So we are thinking that all the things that we can do on materials, the new way of buildings, materials, will be a gain for all the six systems for the future. And the second one, which has been created just 1 month before, is called non-electrical application of nuclear heat, because we all believe that tomorrow we will not have to deliver only electricity, but nuclear heat also for all the system to decarbonize all the energy mix.
Thank you very much. I think I'm going to ask you to look into your crystal ball, if that's okay. And if we were to repeat this discussion in 10 years' time, what topics or areas of nuclear innovation would you like to be discussing, or do you think would be most prevalent?
if we say that we can list the huge amount of innovative systems that we have implemented in the nuclear reactors, but all these innovative systems were not developed only for nuclear, but for science in general, I think it will be the best thing that we have done. Because in that case, it would mean that we have taken the opportunity to all the efficient worldwide R&D that was developed in technique to implement it inside a nuclear reactor. And so in that case, we save time, we save money, and we were efficient. And so it is something I really would like to have. So of course, we are talking about, and we are thinking about advanced manufacturing, which is not only devoted to nuclear reactor. We are talking also about artificial intelligence and all this kind of cross-cutting subject. And we can say that the huge list of systems has been implemented now in nuclear reactors. So we have made a good job in that case, 10 years after. If I'm coming back to 10 years before, when I was younger, 10 years before, and I'm going back to what I was doing, at that time I was a project leader in nuclear technology. My feeling is 10 years before, sometimes I was a little bit frustrated because I was developing very interesting and innovative system, but that was not accepted for budget for the future. So in fact, I had developed some systems, but Kairos was not here. So it was not the opportunist time. And so there was no continuation of the system, at least in France, and where in the labs that I was developing. I can say one of them, for instance, it was supercritical CO2 cycles. I was very fond of these systems, but the budget was not extended in France. It was extended in some other countries. So when I was younger, I was saying, oh, they do not understand what I was making, and so I do not have the budget, and I was very frustrated. Now I'm 10 years old, so I get a little bit more wisdom. And so I should say that sometimes what is making the decision is to be attractive and communicative, and not being only in science. Because the decision makers and the financiers, they are sometimes not scientists, and you have to spend time to be attractive, that's all. And so this is something 10 years ago I should have made better in order to develop my ideas. So once again, a relationship with time, you have, of course, to define what is important, what is interesting for the future, but you have also to define how I will sell this, but selling not with money, but with attractivity. To say, this is Kairos, to say, I'm taking this opportunity because I'm trusting to these innovative systems. And so this is a big challenge when you talk about innovation. We're starting with a small budget. You see that it is very interesting, and after you want to increase your budget to develop it. And when the slope is rising and going up, in that case, you have to be very convincing to have the money back and to have the money makers supporting you. And it is a big challenge that you have to take into account anytime. Innovation and science, it's a good thing, but you have to be convincing to the other person that what you are making is the best solution for the future.
That's great, and another really interesting insight. If you enjoyed this video and would like to hear more about nuclear innovation, don't forget to check out further videos in this series on World Nuclear Association social media platforms. In addition, this video will be available on www.worldnuclearforum.com, where you can also find out more information about our upcoming eForum on Innovation taking place on the 23rd of June, during which the exciting panel will be elaborating further on some of these topics.